So let's check this problem out. And you would think that this is very, very, very similar to the one we just solved. However, I wouldn't say, you know what, let's just do it. Let's just solve it like we did. Um, and let's get to practice. So we're going to analyze this. The thing I noticed that's differently about each of these is it says the word constant speed. And it even gives us what that constant speed is. Zero point 0.2. I don't think that that's going to make much of a difference as much as it's as telling me that it's at a constant speed. Okay, so here's what we got. We want to analyze all of this. And we know that it's 30 degrees. And they told us that the mass is equal to 100 kilograms. Okay, fine. I already know the force of gravity. That's mass times gravity, mg, which is equal to 100 kilograms times 9.8 meters per second squared, which gives you 980 newtons. That one's pretty easy. All right. Now, what we're going to do is we need to break this guy. See, we're going down an inclined plane, and so we have to break this inclined plane into kind of tilt our heads as far as the axis goes. And so this force of friction and force normal, they do not change. However, the force of gravity, the weight, that does change. Now, wait a second. My save thing, I accidentally pressed it, so it's going to come up, and then I'm going to have to tell it, no, I didn't want to actually save. I was just trying to undo, and then I'm going to yell at it, and it's going to yell back at me, and, we're just not going to be friends, so come on, computer. Figure yourself out. Alright, well, let's keep moving on. Not responding. It takes so long. It's either that or I'm so impatient. Mr. Dalday, why are you so impatient? Alright. So what's happening is your normal force. I got a question. My question is this. Is your normal force the same as 980? And I think that the answer is no, it's not 980. Because really, in order to balance this out, if you look at this, the only force that you need to balance between these two is this force, and then you got to break this guy up into its components. So anyway, I forgot. I kind of lost track as to where I was at, so let's just keep going. Yeah, what I was saying is if you change your coordinate system, then this force of friction and this force normal, those are now aligned with the coordinate system, and then this weight, that is no longer aligned with the coordinate system. So, you have a WY and a WX. What is WY and WX? Well, let me draw the picture again to make it look a little bit more pretty. This is WY, this is W, here's theta, here's WX. So WY is equal to W cosine theta. If you don't believe me, use SOHCAHTOA and figure it out. And WX is equal to W sine theta. And we're all good in the hood. Okay, cool. So let's add up the forces in the y direction. Mass times acceleration in the y direction. Alright, so adding up the force in the y direction, there is no acceleration in the y direction because it's not moving up and down. It's actually moving right and left. Very good. Okay, so adding up the forces, I get that the force normal minus W cosine theta, because it's WY, is equal to 0. Oh, okay, so that's saying the force normal is equal to the weight, which is 980 newtons, W cosine of 30 degrees. See, W cosine theta. Oh, that's it. Okay, good. Now let's add the force in the x direction. Now, if I add up the force in the x direction, mass times acceleration in the x direction, here's the kicker. That acceleration is 0. Why is it 0? Because, as I said earlier, constant speed. So therefore, if I'm adding up all the forces, what do I see in the x direction? I see this guy right here, and I see a little bit of the force of friction. Okay, so it's saying that Wx minus the force of friction is equal to 0, or W sine theta is equal to the force of friction. And that's really it. We solved both of them. They asked for the force of friction and they asked for the normal force, and that's what it is. They didn't ask for mu, but if you wanted to solve that, that would be pretty straightforward. It'd just be W sine theta is equal to mu times the force normal. This being the force normal, of course. So it would be N, oh, I'm sorry, not N, it's W. W sine theta equals mu times W cosine theta. If I divide both sides, because I want mu all by itself, the W's cancel. That's crazy. So essentially mu is equal to sine theta over cosine theta. And if you know trig, that's actually equal to tangent theta. Isn't that crazy? The mu is actually equal to tangent theta. That's cool. All right, and since we have a different situation in this case, how does our answers change? Well, the numbers are definitely going to be different. Your normal force is going to be different because you have a steeper angle. Your force of friction is going to be different. Your force of gravity is going to be different, obviously. Actually, no, your force of gravity is going to be the same because it's the same block, 100 kilograms. But see, the beauty of solving things only using variables is essentially you're telling me that you want to plug in different numbers into those equations. The equations stay the same because it's the same situation. You're just changing a little bit of the variables. Well, then you're going to have the same answers. So I'm not going to solve this again. It's going to be the same kind of deal. Anyway, physics!